Okay, recording started. So welcome everyone to the SIG On-Prem weekly meeting. We have a very short agenda for today. So review action items. So actually, regarding the face-to-face meeting, I'll keep on the link. It looks like there's nothing officially planned. So other SIGs are also discussing meeting in some neutral venues, or there are some proposals to meet. I know that SIG Lifecycle will be meeting probably in Weave Networks office. Well, at least that was the proposal. So I'll try to talk to other guys. Maybe we'll find some place. But the question actually is, do we want to just, go to the city, grab some beers, or do we want some official venue, meeting place, or what's your preference actually?
Combine this life cycle.
Sorry, what was the question?
I was just suggesting maybe combine with life cycle guys.
Yeah, we could, I think, yeah. Well, there's I think there's a overlapping list of members probably. Okay, that might be a good idea actually.
Well, I have one note that we have discussed during the last community meeting on Thursday. So we already have the spreadsheet. I have created a similar one as I've created for KubeCon Seattle, with the list of all the SIGs that we have in Kubernetes community, where these SIGs may base their proposed time and venue for their meetings, just not to overlap with others, and to have ability to coordinate. I have shared the link in the chat, so feel free to use it.
Okay.
Speaking about also abilities to meet, probably Thursday. Sorry?
Oh, I think.
Okay.
Yeah, it was just noise.
Yeah, sorry. So speaking about the day to meet, I would propose Tuesday as the day, Tuesday before the official start of the KubeCon. At the same time, there will be happening some meetups in Berlin, Kubernetes related meetups. So if someone would like to attend them, so we have to define the best time for us, just not to overlap with them.
Yeah, I remember from last KubeCon, not everyone was happy about the meetings on the day before, because people were also coming, on Wednesday. So yeah, this sounds good, but I'm not sure if this is the best idea actually.
So you would propose having a meeting on one of the days KubeCon, on Wednesday and Thursday?
Well, I think I will just review the spreadsheet and see how it looks like, and the KubeCon schedule, and then propose something on the mailing list. So we can do it offline, I guess.
Yeah, I will also share with you the sample spreadsheet from Seattle, because actual KubeCon spreadsheet for Berlin is empty at the moment, but Seattle spreadsheet was filled enough, so you may use it as a sample for scheduling your activities for this SIG.
Okay.
Yeah, that's all from me.
All right, thanks, Igor. Actually, next action item is also related to your request for the roadmap for 2017. So after discussing with other folks, we won't be able to provide roadmap for entire 2017. For 1.6, we don't have any work planned, significant work driven by SIG On-Prem. We're still working on identifying this stuff, so we might have some roadmap for next release. I will work on this and provide you with an items. So that's all from action items. And next item, next point in the agenda is actually a demo. Oh, surprising change of presenter. So yeah, I thought Jorge will be presenting, but it looks like
we're doing it together.
Okay,
We're kind of interchangeable. Yeah.
All right. So Marco Ceppi and Jorge Castro from Canonical will present Kubernetes on mass and with Juju. So who will be driving this? Who should?
We definitely want to share Marco's screen here.
All right. Let me stop sharing. Okay. All right.
And then last time, while people ask questions in chat, I'll just relay them over to Marco so he can just seamlessly answer them without having to track chat, which is kind of how it worked for last week's demo.
Okay, Marco, I think you're the host now. All right, I see.
There you go.
Okay.
Oh, can you all hear me okay?
One note though, I think there's someone with a lot of background noise, like cars in the background. I don't know who's that, but it would be good to mute.
Go ahead, Marco.
Yeah.
I can hear you.
Okay, great. You guys can hear me. So I'm going to quickly kick this off, and I'm going to describe what's going on as it's running in the background here. So I'm just going to walk through this real quickly, then we'll come back to what actually happens. Okay, so what we're doing here is we're deploying Kubernetes onto bare metal today. So this is going to walk through. It's going to be a bunch of steps. It takes about 15 minutes. So I want to start it real quickly. I'm not sure if it'll finish by the end of our slot for demonstrations. But I wanted to show kind of what's going on. So we're using Maz. Maz is Metal as a Service. It's kind of like an API for your bare metal. It's being used quite a lot in the industry. Bloomberg, Deutsche Telekom, AT&T, others are using Maz as a way to then put an API in front of their bare metal. What this gets them is cloud-like attributes for on-premise bare metal provisioning. So instead of having to go down with a cart, some guy to press a power button somewhere and hook up a bunch of power lines and networking cables, what you get is an API where you can say, I want this machine with this characteristics to have this operating system on it. Maz will provision that and then hand back access to it, kind of similar to what you get in Amazon. I want this size machine with this operating system on it. So Maz itself deploys a wide range of operating systems from Ubuntu, which we're doing today, to CentOS and RHEL and Windows. Any operating system you can kind of provision on a piece of bare metal, you can do through Maz. So what Maz does for us is gives us, well, networking and configuration management. So for example, here I've got nodes that are being deployed now because I've requested them. But what I could do with these nodes is I can actually configure the networking beforehand. I can say, in this case, I have 2 NICs. There's a small rack of 10 machines down in my basement. They're not like 2Us or anything. They're Intel NUCs, but they have remote power management. So I can configure things like the networking interfaces, if they should be on tag VLANs, what VLANs they should be on, static or dynamic IP address allocation. I can configure the storage partitions for these ahead of time. So I can kind of basically imprint what I want this machine to look like when it boots up. Bare metal provisioning is a really hard problem to solve. It's one that we've been wrestling with for quite a while. It's something that we've had problems with since the early days of OpenStack. OpenStack works best on bare metal. How do we get that to provision up? So Maz was a tool that we kind of created. It's a free open source piece of software to do that dynamic allocation of hardware, where things like Juju in this case can plug into it. Chef's Knife Provisioner also plugs into this, and because it's just a simple API endpoint, really any tool can consume it. It's just a RESTful endpoint, kind of like all the cloud resources you have today. So in addition to what we see here, which is a machine being booted up, you could do a lot of different things. You could do different power types for machines. I'm using Intel AMT because that's what's on the Intel NUC. But you could do anything from like ILO to IBM hardware management consoles to APC PDUs to even VMware and Versh. So if you wanted to manage some IPMI-based bare metal alongside your existing VMware infrastructure and have that as through one access through one API. Maz has the ability to do that for you as well. It also takes care of a lot of the complex problems that you get with bare metal provisioning, like the quirks modes between different versions of IPMI, whether it's IPMI 1.5 or IPMI 1.5 by one vendor, which is additional implementations to the standard that don't exist, or IPMI 2.0, which is a little bit cleaner. All of these things are taken care of at this provisioner level. So what we get is the ability to dynamically enlist a bunch of hardware, which we're doing right now. I'm booting up, which will be a sum total of 9 machines in order to deploy these 9 components for Kubernetes. And I'm doing it in a way that's repeatable in implementation. So we used ConjureUp to get to this point. I'll walk through what that ConjureUp looked like in the beginning. But basically, we're just waiting for hardware to allocate. So while we're waiting for those things, I want to walk through what we just did to get to this point. So I'm going to come over here. I'm going to run ConjureUp Kubernetes again. So ConjureUp is kind of a UI installer on top of Juju. Basically, what it gets you is the ability to kind of walk through with a visual, textual-based visual representation of the piece of software you're about to install. So this has support for Kubernetes. It's not solely built for Kubernetes. It spans a wide range of topics from installing things like big data onto bare metal or things like OpenStack and stuff, but it works really well for Kubernetes as well. So we chose the canonical distribution of Kubernetes, but we also have a core Kubernetes, which is a smaller, just a 2-machine Kubernetes cluster, which you could deploy onto bare metal or VMware or OpenStack or any of the public clouds. But we chose this, and I'll kind of walk through what each of the components are and everything. So, oops, let me go back real quick. So when you choose a thing you want to actually deploy, it gives you a list of places to deploy that to. So we're doing bare metal. My bare metal rack downstairs is called something really concise. It's called USDC 001. But this is just the name of my bare metal cluster downstairs. I could also point to things like public clouds, GCE, Cloud Sigma, Azure, AWS, Rackspace. I could configure a VMware cluster. I could configure my local machine to be deployed here onto containers on my local laptop or local hardware. In this case, I'm just going to go ahead and choose my piece of bare metal. And then I'm proposed with the architecture screen. So the distribution of Kubernetes that we produce, we call it CDK for short, canonical distribution of Kubernetes. It comes with TLS encryption out of the box. So we roll our own PKI using EasyRSA as a certificate generation. This could be swapped out for either if you have your own on-premise PKI infrastructure already, or if you wanted to use something like Vault instead for PKI, you could switch these components out. But the upstream docs have recommended EasyRSA as the way to do certificate generation, so we have that as a deployed component. From there, we deploy 3 units of etcd. You could change this, though. You can configure this to say, I want 5 or 9, or I want to run really lightweight and just have it be 1 machine or 1 unit of etcd. This also will get TLS certificates from the EasyRSA component, so it'll be TLS encrypted between the peers as well as access to the cluster will be secured and encrypted. We use Flannel as an SDN overlay. It's not the sole SDN provider we support. You can use Flannel, you can use Calico, you can use Flannel and Calico if you're deploying onto the Azure, which doesn't have a flat subnet to deploy to, or if you're deploying into a mixed subnet space on bare metal or in VMware. You can use Flannel to present a single solidified subnet, and then you can use Calico for your routing and BGP policy. Finally, we have the master component. That's Kube API server, Kube scheduler, and the other components that comprise the API control plane called the Kubernetes master. Then we have the Kubernetes worker. That's kubelet. That's the container runtime, in this case Docker. It's also kube proxy, and then CNI components are installed there as well. And so those are kind of the control plane versus the worker node control plane, node deployment. And then we have an HA proxy load balancer that we deploy on bare metal so that you can scale up your number of masters in order to produce an HA deployment so that you can then load balance not just from the clients into the cluster, but also from the Kubernetes kubelet nodes talking to the API server will be load balanced through there as well. So you can deploy the Kube API load balancer component, which is again just HA proxy with an optimized configuration. To do it, you can do it as 2 kube load balancers so that you can do virtual IP failover between them and have a completely HA deployment. Go 9 nodes of etcd, 2 nodes of your load balancer, 3 nodes of master, and then any number of workers or worker groups that you want to deploy for Kubernetes node. From there, we just went and hit deploy these applications, and that's where it brought us to this screen here. So As you can see here, a number of things are happening. We've got components being installed. EasyRSA has been installed. One of the etcd machines have been installed. Another one's still running. It's generating certificates it needs in order to be a cluster. It just finished that generation. We got another machine, another etcd cluster node that's waiting. Because this is all an asynchronous deployment, you can see here machines are still being booted. A couple machines are still being installed. Bare metal is, well, slow by nature, I suppose. In order to lay down operating systems, disks, boot them up. They're also Intel NUCs. They're not super performant machines by any stretch of the imagination. But because we're using things like Juju and Conjure Up, we're able to actually manage a distributed asynchronous environment and the lifecycle events that go around there. So components will block and wait for completion if there's still not a completed component in the architecture they need to deploy. So we could sit there for a few more minutes, but I want to show.
Yep, while that's going, I'm going to go ahead and toss some questions at you.
Yes.
What about shared storage support?
Yeah, absolutely. So our Kubernetes cluster does support shared storage. Right now, out of the box, it supports NFS mounting and Ceph. We're adding Gluster support in real soon, and any other kind of shared storage that we can get our hands on. So this will use the disks on that bare metal machine for like instant store and stuff. And then if you have a Ceph cluster or you want to deploy a Ceph cluster on top of those, you can actually do that as well and use Ceph for your block devices or NFS mounts if you have those already running somewhere.
Yep. Someone asked if MAS will support Dell and Redfish.
That is a great question. Not one that I know, but I can follow up with the SIG. I know we've talked to Dell about Redfish. I believe that it's on the roadmap if it's not already there for MAS. So if we go to a node real quickly, let me see if it's just listed in the power types.
I don't think it is.
I don't think it is yet, but we absolutely would be tracking that stuff for sure. So there's Facebook's wedges in here. I'm sure that we'd have another one for, what's going on? Get rid of that.
Yeah. It's fine. We had more questions, so I'm going to move on.
Yeah, I have one.
Yeah.
Sure.
How does so I'm Metal as a Service software systems are interesting for me. And have you compared MAS versus something like Tumblr's Collins?
I haven't looked much at Collins, so I can't answer that intelligently. Okay. But that was something they recently released, wasn't it?
Oh no, that was like 3-4 years ago.
Wasn't that the system that was Cobbler based? Or did they do their own thing?
They might have had so it was released. So just to give a quick thing, at SoundCloud we implemented a Collins server to manage all of our bare metal. So by the time I was done, we were about 1,700 servers in Collins bare metal management, and it was implemented because it had a really it didn't actually have Debian support. So that was something that we wrote internally, but that was just a matter of building the Debian installer stuff. So it supports whatever you can. I think Cloud Init would be more modern. I don't know if there's what they have for Cloud Init, but we did all the stuff to get like Debian and Chef integrated with it. But it's basically a big state machine database. So anything you can implement in the state machine you can handle. And the interesting bit is it has a really fantastic setup for doing intake. So the way SoundCloud had servers delivered was we deploy a top of rack switch. Another vendor would come in and just shove the servers into the rack, wire them up, hit the power button, and walk away. All the servers would pixie boot, discover where they were physically on the network, and the Collins server would assign static IPs to everything.
Yep. So MAS does a very similar thing. I didn't show the dashboard here, but I've got a quote unquote top of rack switch. It's like a Microtech layer 3 switch downstairs. Mm-hmm. And I've got a bunch of things I plugged into it that it's discovered. It's asking me what I want to do now. I can nope, that didn't do what I wanted it to. I can effectively enlist these. So these already had an operating system. So if there was no operating system, it would have delivered a PXE to it, then a commissioning of that hardware to get an inventory of it. It already had an operating system on it. So instead what it does is simply does a probe. It gives it an IP address and it says, this is what I found. I don't know what it is on the device. You can say it's a device, it's an interface. You can give it, oh, this is the power management port, these are the parents. And then you can just say, add it into my inventory or just ignore it. So these are, I don't know what these are. I wish I knew what I plugged into that stack. If I showed you a picture of my basement, it would be a nightmare for any real network operator. But
it does have a Pixie inventory prober.
Absolutely, yeah. So you can, if you power them on, it'll go, the top rack switch is configured to do so. It'll just simply go, oops, wrong one. It'll simply go and inventory that thing. That's how we get the things like the CPU cores, the memory, the disk configuration, the NICs, all that was dynamically commissioned on the first boot of that machine. It does like a commissioning process.
Nice. So it has some fairly similar functionality.
Yeah, I'd be happy to take a look at that. These came out about the same time, just about 3 or 4 years ago for Tumblr's thing. Maz has been a product we've had for about the same time. I'd say about 4 years or so. So it sounds like
yeah. Unfortunately, there's not enough, like, since especially in the last 5 years, there's not been any discussion about different systems for this kind of thing. So there's a bit of silly competition where we need a really good option. And this is nice because that's actually one of the biggest biggest annoyances with Collins is it has no support for discovering your cloud boxes. So if you have an EC2 account, like having mass also tie into your EC2 account would be awesome.
So yeah, we could absolutely do that. We have, we don't have it today, but the way you write these power adapters, it's like 10, 20 lines of Python code to bridge to whatever you need it to. So you actually have things like Verse support. So if you have Verse running somewhere or VMware, it'll use your credentials to say, here's a list of existing running machines already, and it can use the power management turners on and off and stuff.
Nice.
Same thing with things like LexD. So adding one for AWS, so you can have your inventory of AWS and bare metal kind of.
That would make a ton of people super happy.
That's super cool. I'll tell the Mass team about this for sure. It is, not to sound like that traditional jingle, but it's all open source software, so we're happy to.
Yeah. So Math is all in Python, or
Maz is the majority is written in Python.
That was the big thing we really didn't like about Collins is it's all in Scala, and it's kind of a thing.
I'm sure it was wicked fast.
No, actually. Well, most of it was actually it is wicked fast, but most of its actual limitations is how fast the MySQL database underneath it can run.
So we are using Postgres under the covers for this. It's been super tuned. It's really great for the kind of things we're doing, and we don't abuse the model in the database. We do as much as we can. We use the database as a traditional database, not as a giant state server, like where something like Zookeeper would make more sense. Or NCP.
Yeah. No, the Collins model is mostly just using it as a big key value store. Yeah.
So we do use it as a relational database model where we inject things like keys, and we have proper relationships model so that you get the nice access dexterity of relations. Not a giant key value store per se. So this is just about
the Collins also has all the relationships there, but it's fundamentally treating it like it's a small, like a very light relational model. But they seem similar in terms of like design idea and philosophy, and like mostly my thing is about having a state manager deal with all of the workflow of your bare metal. So something is active or in maintenance, and dealing with it, like when you're dealing with bare metal, it's all about dealing with the transitions between these states. And so my big bare metal experience was running Google's bare metal. And we had a giant state database that managed all that, and but the inventory stuff was a lot less automated in terms of intake. But once it was in intake, every automated system interacted with that bare metal database to deal with the state and dealt with the state there. So you could just what you would in the Google world, you would just tag. You would tag a piece of bare metal as doing something, whether it was a kubelet or or some other task, and then automated systems would just do the installation piece. Where I think the new model with Mass and Collins is the state database takes a more active role in this thing.
Yes, I would agree to an extent. We're pushing that way here with things like Mass. So we took a really early on view, like where does the boundary between bare metal provisioning end and where does workload begin? And one thing we were cognizant of when designing Mass was there are a bunch of ways to install software today. I mean, at the time we were building this, it was like, it was Puppet and Chef for like the pressing forces for configuration management. But with the explosion of everything else in the market, with Salt, Ansible, we have Juju as well, and then we have, going even further, the Habitat and others that are taking that next step, and then even to a sense of Kubernetes as well, which is a way to rapidly distribute applications in Docker. So what we took was the idea that the line ends the same place that Amazon's base EC2 instance ends, is that you go to the marketplace, you want an image, you tag that image, you can add cloud metadata user data for Cloud Init. So this uses Cloud Init for delivering its post day zero config, basically. And from there, you'll get back from the API or from the CLI or from the web UI, you get back an IP address that you can log into for that machine. And then anything else from that point over can take over. Ansible can add that to its inventory. Chef's Knife Provisioner will do the proper things for managing that as well. And most everything else can most of those tools that were speaking native EC2 APIs, we figure, well, if they had one API for bare metal, do the same things EC2 provisioners do. And you get similar features. You could tag these things, so you use taxonomy to help line them up. We also have the idea of failure zones. So you can say, oh yeah, I've got, in my case, I have 3 zones in my basement, which isn't really accurate, but for demonstration purposes, we have large data centers that'll say, oh, well, we have 3 or 4 data centers that have all redundant networking and power in the same region. So we'll have these marked as zone 0, 1, and 2 as availability zones for bare metal. And then the applications using Maz's API could say, I need this, but I need it in a place that isn't also already co-located with this same application. So if you look at, let me finish this run through here. So the bare metal runs.
Time check there.
Yeah, sorry. Boo, I hit an error, but that's fine. The cluster is deployed, so I can go ahead and just query this with Juju now. See which one. This one that we did. I kind of angered it by running 2 conjures up at the same time against the same cloud. But we have here that same model we've deployed. So let me just watch this. So we've got the same components. This is kind of the post-installation. You can see the topology is deployed. This is all live and querying. We've got EasyRSA, etcd, Flannel, load balancer, master worker. We've got 1 unit of EasyRSA for our certificate authority, 3 units of etcd, and they're all clustered together. We've got a Kube API load balancer doing our load balancing. We've got a master. We've got workers, and we've got Flannel on all of those across those in the subnets that Flannel's mapping for these things. So I'm going to just go ahead and grab my kube config. I can run a kubectl cluster info. I've got, this is my bare metal deployment. These are the IP addresses. Master's pointed at 2525. That's probably it's probably my load balancer.
Give you 2 quick questions while you're having to do that. Networking support, Calico, Weave.
Yeah, so Calico, Flannel are out of the box right now. We're working to get Weave added for sure. We're really interested in getting their SDN in here so you can model it. All these things are swappable. So right now we've got Flannel deployed, but you could at any time say, I want Calico, deploy Calico, add Calico in there. Then you've got Calico's policy management on top of Flannel. You can redeploy this with just Calico. You can redeploy this theoretically with Weave as well, or any other SDN that supports CNI in Kubernetes you can deploy alongside of here.
Yep. And the question, what is the load balancer?
Yeah, so the load balancer, in this case, is just HA proxy with a tuned configuration to manage routing traffic through to the Kubernetes cluster. We started with Nginx, but we found that layer 7 routing with Nginx was kind of problematic for things like kubectl exec and Docker exec into the cluster. So we switched it to HA proxy. It just uses the standard layer 4 routing. So it's just TCP forwarding basically into the cluster. And in this connection, it's actually the workers go through the load balancer to talk to the master. So what's great about this is because this model is, well, it's not just an installer, it's also lifecycle. So if I wanted to add another master, if I wanted to scale up my master components or nodes, I could just say Juju add a unit of Kubernetes use master. And so what this will do, if we watch the output here, is it'll just go and add another unit of master. It'll go and dynamically allocate the hardware for this. So by using NAS, or a bare metal tool that gives us an API to that bare metal, we can actually do things like auto healing, auto scaling, and manipulation of a deployment past just day 0 and day 1. So this will go and allocate. I think it's probably already allocated. My last machine in the rack will be node 10. In a few seconds, this will just switch to allocating. We'll deploy an operating system, and it'll replay those same set of configurations. It'll make sure that the master has flannel installed. It'll make sure master knows about the other master, the load balancer, and then the workers won't have to do anything because they're all pointed at the load balancer. It'll also make sure it knows where the etcd is. All that configuration we just did on that installation phase will manipulate over time. So the idea behind using things like Juju gets you that life cycle management from scaling up and down, manipulating the model and configuration, changing things and being able to do so. This includes upgrades. We're at 1.5.2 today for Kubernetes. We're at 1.5.3. When it comes out, we'll be upgrading there as well. And there's an upgrade path for a live running cluster. And we're also just about done with our upgrade path from 1.5 to 1.6, including the etcd migration. So for those running clusters, this also encapsulates that same upgrade story and flexibility. The last thing I want to show is this here, which is the same model. It's Kubernetes, the same components we just saw here before, but it's running against AWS. And that conjure up dialogue before, the important thing is with using Juju per se, is you get the same components, the same code that's doing the same operations across public clouds, private clouds, and bare metal, VMware, bare metal direct, etc. And these are all the code for this, how we deploy the etcd, how we deploy the master and workers, is all in the cluster Juju directory in the upstream Kubernetes repo. So if you want to go poke to see how we actually manage these lifecycle events, how we manage state, how we can handle crazy asynchronous operations in a live world, it's all sitting up there for review.
All right, and I think that's it. Any more questions? Sorry to rush you through that. I was just cognizant on everything.
Yeah, no, I always trip into really good conversations about bare metal provisioning, and then I always lose track of time. Cool, thank you. Again, I hang out in the on-prem SIG with George. If you guys have any questions about this stuff, Maz or Juju or Contra in general, please let me know. I'm happy to help answer them. I really think that on-prem SIG should really focus on figuring out the hard problems for on-premise. And one of those things is definitely bare metal provisioning in a sane fashion, whether that's something we help curate a set of tools that can do that we recommend people that are building on-prem solutions plug into to take care of provisioning, or just discussing the nuances of how to handle that kind of provisioning of resources and operating systems. It seems like a challenging but worthy problem to tackle.
I have one question, and don't worry, guys, we still have time. That's the last item on the agenda, really. So, what about Kubernetes upgrades? So, do you guys? I don't know Juju very well. So, how does it handle upgrades of the charms or of the software, etc.?
Yeah, absolutely. So. There's kind of two upgrade paths. There's the upgrades of the operational scripts, the charms, these components, these 6 components we've installed here. Those are charms. They're just little bits of operational code. What happens during this lifecycle event, what happens during this event, etc. Those are separate than the actual application version. So you could upload new versions of the application. You could just simply say, hey, I've got a Kubernetes tarball here that I've downloaded. It could be a beta release. It could be a one-off fix that you're doing. And you say, hey, Juju, attach this resource to this component. And then it'll go through, properly unpack that, put the binaries into place, and then update the the system D scripts to point to that. So we handle upgrades in that same fashion, where we republish effectively the same Kubernetes blobs along with these. So when you deploy them, you get in this case, 1.5.2 release. When 1.5.3 comes out, we'll update the same blobs again, make sure they point to the 1.5.3 release, and then we publish them along with the charms so that you can do offline deploys. That way, we're not just randomly grabbing stuff from the internet and throwing them onto disk. A lot of on-premise customers of ours have limited egress environments or no egress environment at all. So you could effectively come in with the charms and the resources as kind of a package on a USB disk, plug it in and say deploy from this location. You'll get, as long as you have access to like the Debian archive to download packages from, and most people have a mirror already on site, you can deploy this whole thing without having to do any lookups to the public internet. As long as you also have a private registry somewhere for the images that are typically hosted in GCR.io.
Cool, thanks.
Yep.
I have another one.
Yeah.
I think I asked on the chat, but I didn't see the answer. So, do you guys use just upstream Kubernetes, or do you just your own package?
No, that's a great question. Yeah,
etc.
We use upstream Kubernetes. We don't have any forks of Kubernetes that we use. All of our releases are just simply the same binaries repackaged for inclusion in an offline environment, basically. So we're not straying from the upstream. We don't have any patches or fixes that we have end up in upstream before we roll them into our solution. So there's no fork of that. It's just a pure upstream Kubernetes release.
Sure, but as we know, upstream sometimes is slowpoke. So, all right.
Yeah, it is. And that's why we have that option. Like if you wanted to roll your own custom fork, you could just simply say, hey, use these binaries here instead. But what we release publicly and what we release as the default is whatever's in the upstream.
All right, cool. So no more questions from me? Any other questions, guys?
I had a question.
Yeah.
What components are run on host versus run in pods on the cluster?
That's a good question. So we could just actually go ahead and kubectl get. So this is essentially what we run. We have a default Nginx ingress controller that we roll with it as well because, well, there's no load balancers or controllers that you use on bare metal. So all of our solutions have a default Nginx ingress controller. You can configure that to point to an ELB or something in the cloud. Then we just run the kubedns dashboard, the influx and Grafana stuff in Heapster in pods. The rest is all binaries on disk.
Okay. Yeah, so it looks like the whole control plane is on the host.
Yeah, the Kube API server, Kube scheduler, and the third one, which I always forget, escapes me. We can go poke at it, but yes, those run on disk.
Controller manager.
Yes, thank you. The Kube controller manager. Then kubelet as well, Kube proxy, the CNI stuff, all that runs on disk, on metal.
Okay.
I have a quick question. How do you handle Kubernetes upgrades itself? So, when it goes to 1.5.2 to 1.5.3, do you do like a rolling restart of everything, or do you decommission nodes and bring them back, or is there just sort of a operator's decision?
Yeah, that's a great question. There's a couple of things that we can do. The first is you could just bring up additional masters with the new control plane. Say, I'm going to boot up 3 more machines of master. It'll pull down the latest 1.5.3 release and then turn down the old ones. You can also just do in-place upgrades. As long as your etcd cluster is being upgraded, you could generally just do, say, hey, I want to upgrade my Kubernetes master to the latest version. All it does is download the new binaries and then just restarts the daemon with the new binaries in place. We test that upgrade path extensively. From our test, it's worked every time from 1.4.4 when we started doing that upgrade path all the way through to today, 1.5.2, and we're getting ready for 1.5.3 now. 1.6.0 will probably be a little trickier just because you have to do an upgrade of etcd first. It might be like a redeploy the control plane and then connect everything up again. But from the worker's perspective, if you want to avoid any downtime where, if you lose your Docker daemon, your containers go offline, it's kind of annoying. We have these built-in operations into the components. So if you do a Juju actions for Kubernetes worker, what this says is it has a list of things that you can do on this as like repeatable operations tasks. So anything you normally have to SSH into to poke at, there's a pause and resume feature. You could do this from the exterior. You could do kubectl. Basically, you cordon the node and then evacuate it. But you could run through Juju. You could run this against a group of machines and say units 0 through 5. I'm going to pause them all. That cordons the node and evacuates all the workloads off of it. Once that's done, you could go and upgrade those components, and then if they come up clean, you could reschedule them again by resuming them. So things like pulling the trigger, you could do blue-greens, you could do in-place upgrades for everything, you could just do a redeploy of the architecture. We don't really have an opinionated way to do it. It's about what you want to do, the speed you want to do it in, and the risk you want to take doing it. We support the range of those upgrade scenarios, including things like this where your hardware just doesn't provision. So I don't know why this node is broken, but I got to go figure it out. But in Maz, I'm just going to mark this as broken so I don't have to deal with this again in future demos. How do I get rid of this? Over here. So if I mark it broken, it won't schedule the node. I can go take a look and fix it now. And then if I had more machines, Juju would just go find another node to put this onto, but it's going to be stuck until I manually intervene. But yeah, upgrades is a really important topic for us. It's one that we try to make sure we cover the most scenarios that operators would want to exercise for the cluster. But in-place upgrades has worked really reliably for us since the early 1.4 days.
Great, thank you.
Cool. And I think that's it for us.
Yeah, thank you very much. That was excellent. And yeah, I think we're learning a lot. So last item is actually the on-premise guide for Kubernetes. So we started working on this, but as we discussed last time, we don't want this to be very biased. So I think we should wait for all the demos. There will be like 3 or 4 more, and start working on this, on the content after all the demos, and we have a good picture what's the state there. To be honest, I'm constantly surprised by those demos. So definitely we don't know all the stuff yet. So I think, yeah, we'll wait until all the demos are delivered. Mm-hmm. So
who's that? Oh, sorry.
Yeah, go ahead, Jorge.
Next week is Rob, I think.
Digital Rebar, I think. I would need to take a look at my notes.
Okay.
Yeah, I'm good for next week.
Okay, awesome.
Cool. All right, that looks like that's all on the agenda. Still 45 minutes. Any other questions? Yeah, 2 weeks. Yeah, in 2 weeks, obviously. Yeah. Mm-hmm. Next meeting. So, any other questions? Oh, Dalton. On the mailing list, I think there's a thread about the demos. So, a couple of people volunteered to deliver. We'd love to see something from CoreOS, obviously. All right, guys. So, any other questions? Probably not. Everyone's happy. All right. Thank you, everyone, then. And enjoy the rest of your Wednesday. See you in 2 weeks.
Thanks, everyone.
Bye.
Thank you.
Thanks. Bye.